What is the composable architecture? The composable architecture is an architectural pattern for building iOS apps using functional programming principles. It is designed to manage the state of an application in a predictable and composable way. TCA was introduced by Point Free and has gained popularity due to its simplicity, testability, and scalability. State management. At the core of TCA is the concept of state. The state represents the entire data structure of your application at any given time. In TCA, the state is immutable, meaning it cannot be changed directly. Instead, the state is transformed by using reducers. Reducers are pure functions that take the current state and an action as input and return a new state as output. They define how the state should change in response to different actions. Reducers form the foundation of TCA as they are responsible for managing the state transitions. Actions are simple data structures that represent events or user interactions in your app. Each action corresponds to a specific change or intent in your application. When an action is dispatched, it triggers the execution of the reducer to update the state. Store. The store is the central piece of TCA. It holds the current application state and exposes an interface to interact with it. The store is responsible for receiving actions, executing reducers, and updating the state accordingly. It also provides read-only access to the current state. View store. The view store is a derivative of the store and represents a read-only, derived view of the store's state. It exposes a subset of the state that is relevant to a specific view or UI component. The view store is used within SwiftUI views to access the part of the state they need and ensure proper view updates when the state changes. Environment. The environment is an external dependency container in TCA. It holds all the dependencies and services needed by your app, such as network clients, databases, or other side-affecting operations. The environment is passed down from the top-level view to child components, enabling easy dependency injection and testability. Asynchronous operations and effects. In real-world apps, you often need to handle asynchronous operations, such as making network requests. TCA provides a clean way to handle these effects using effect types. Effects are returned by reducers and are used to describe asynchronous operations. They are then executed by the store, and their results can lead to further actions that change the state. SwiftUI integration. TCA integrates seamlessly with SwiftUI, Apple's declarative UI framework. You can use the TCA architecture with SwiftUI's views and combines publisher-subscriber pattern to build scalable and reactive user interfaces. Composing complex modules. TCA encourages breaking down complex functionality into smaller, reusable components. These components can be composed together to build more extensive features or entire screens, promoting modularity and reusability. Testing and debugging. TCA's functional nature makes it easy to write unit tests for your reducers and business logic. You can assert the behavior of your app based on different actions and state transitions. Additionally, TCA provides excellent debugging support with clear action logs, making it easier to track down bugs and understand your app's behavior. Error handling. TCA offers robust error handling mechanisms. Errors can be represented as part of the state and handled within reducers, providing a clear and predictable way to deal with failures. Tips and best practices. As you gain experience with TCA, you'll discover various tips and best practices to enhance your development process and make your codebase more maintainable and scalable.